Hi everyone, welcome to my channel. Today we are going to explore the world of networking and dive into one of the fundamental protocols that make the internet work. That's UDP. UDP stands for User Datagram Protocol. In that UDP, let's get started. UDP is one of the core protocol of the internet and it's a connection protocol, meaning it doesn't establish dedicated connection before data is transmitted. This is in contrast to TCP or transmission control protocol, which requires the connection before transmitting data. Then the UDP is very fast, efficient but unreliable, making it suitable for real-time applications like video streaming, online games and voice over IP. In this video, we will cover the UDP header format, error reduction, applications, advantage and disadvantages. And then we are going to discuss about the UDP header format. Let's take a closer look to the UDP header format. As you can see, it much simpler than TCP header. We have four fields like source port, destination port, length and checksum. The source port identifies the sender's application, while the destination port identifies the receiving application. The length field specifies the total size of the UDP datagram, including the header and data. And finally, the checksum field is used for error reduction, but it is optional. And then we are going to discuss about connectionless communication. So, how does UDP work? Well, we will discuss about that. Unlike TCP, UDP doesn't require a handshake before data is transmitted. This means that data can be sent immediately without waiting for acknowledgement. Think of it like sending a postcard. You write the message, put it in the mail, and hope it reaches the recipient. But you don't get any confirmation that it actually arrived, because we don't. If we don't receive a reply mail, we didn't confirm that the mail reaches them. So if they reply to us, then only we want to know that the mail is reached them, like that. And then we are going to discuss about UDP error reduction, that means checksum. Now let's talk about the error reduction. As I mentioned earlier, the checksum field is optional, but when it is used, it's calculated based on datagram and verified at the receiver's end. If the checksum fails, the packet is discarded, but unlike TCP, UDP doesn't retransmit lost packets, making it less reliable. And then UDP uses an optional checksum, and also if a checksum fails, the datagram is discarded. The absence of a checksum doesn't guarantee error-free delivery. And then we are going to discuss about UDP applications. The one of the application is speed matters. So where is UDP used? Well, its speed and efficiency make it ideal for real-time applications like video streaming. Video streaming means like we use many social medias like Instagram, YouTube. These are all the examples, and also online games and voiceovers for IP. IP voiceover means in a cricket they were voiceover like they are matching like that. And then for example, when you are watching a YouTube video, UDP is used to stream the video content to your device. Similarly, when you are playing an online multiplayer game, UDP is used to transmit your movements and actions to the server. It's used for that don't interrupt between our connection with the internet. And then we are going to discuss about the difference and which one is best to the comparison between UDP and TCP. Now let's compare UDP with the TCP. As we discussed earlier, TCP is a connection-oriented protocol that ensures reliable delivery, while UDP is connectionless and doesn't guarantee delivery. TCP has higher overhead due to its additional features, while UDP has lower overhead. And finally, TCP is best suited for applications like file transfer and web browsing, while UDP is better suited for real-time applications like video streaming and gaming, because TCP have a connection to the data before it's sent, but UDP doesn't want that connection to the data before it's sent. And then advantages of UDP. So, what are the advantages of UDP? Well, its low latency and reduced overhead make it ideal for real-time applications. Additionally, UDP supports broadcasting to multiple devices, making it useful for applications like network discovery and video streaming. And minimal delay in data transmission, and it reduces smaller header size compared to TCP, and its efficient delivery to multiple recipients. And then UDP offers resource efficiency, and it leads to lower CPU and memory usage. And then we are going to discuss about disadvantages of UDP. Now, what are the disadvantages of UDP? Well, it's an unreliable delivery, means that packets may be lost or arrive out of order. That means the datagram may be lost or out of order. And then no congestion control. That means that UDP can lead to network congestion. Congestion means it's a group of datas are fight for each other. That's like called congestion. Additionally, UDP doesn't regulate traffic, which can lead to network congestion. And finally, its connectionless nature makes it vulnerable to attacks like DDoS. And then UDP in practice. UDP in practice. So, where is UDP used in practice? Well, it is used in DNS. DNS means domain name system. That's used for resolving domain names quickly. And then that's used to ensure fast resolution of domain names to IP address. And then it is used in TFTP. TFTP means Trivial File Transfer Protocol, that is transfers a simple file to the protocol. And then we are going to discuss about QUIC. QUIC means that combines UDP with reliability. Reliability is nothing but redundancy, copies of that data. And TFTP is used for simple file transfer with minimal overhead. And SNMP used for network management protocol. And then we are going to discuss about the UDP NIC as a conclusion. In conclusion, UDP is fast and efficient protocol that's ideal for real-time applications. While it may not guarantee reliable delivery, its speed and low latency make it perfect for applications like video streaming, online gaming, and voice over IP. And its essential service is UDP provides service in specific scenarios, and the understanding of crucial for network engineers. It gives more understanding, and its connectionless, and also it's very useful for real-time applications. To that, network engineers are easy to understand what the concept of the UDP. And then QIC shows UDP continued relevance, and also its very speed and efficiency for real-time applications. These are the contents for UDP. And also, if you want to know more, you can comment me. And also, thank you for watching, and don't forget to like, comment, and subscribe for more videos on networking and technology. Thank you.